All right, everybody. In this video, we're going to talk about section 4.4, which is officially titled Trig Functions of Any Angle. And this is just going to take us, again, further away from the unit circle and just make sure that we're looking at our trig functions in multiple ways. To start, I've got several warm-ups. They're going to take a little bit of time. I'm going to try and cruise through these pretty quick. As usual, please pause the video and try these on your own first. I think it'd be a good idea before we get started here. We know all our usual trig functions, the way of converting, cosecant is 1 over sine, secant is 1 over cosine, tangent you can write as sine over, all those things. But I want to remind you of the three Pythagorean theorems, Pythagorean identities. And the main one is that we have sine squared theta plus cosine squared theta equals 1. And that's the main one. And honestly, that's the one I've got memorized and will have memorized forever. And then there's the other two. And I know the other two involve relating cosecant squared and cotangent squared, but I get, unless I'm just looked it up and just use it, I get confused about what goes where. For whatever reason, I just haven't memorized that. But I don't need to memorize them, or I can at least have a backup when I forget, because the other two are created simply by taking this one. And if we're going to do number 2, and again, I'm just naming them, they don't have any special order. I'm going to divide everything in this main one by cosine squared. And I can almost just do it in my head. And I can see that I get sine squared over cosine squared. Well, that is tangent squared. And I should be more precise. We're dividing by cosine squared theta. And cosine over cosine, so that's cosine squared over cosine squared is 1. And then 1 over cosine squared is secant squared. So I should have this memorized. Like, it'll help me do the work. But what I do at least have memorized is I know that tangent squared and secant squared are related. I just never quite remember like where the 1 is, right? But I have a backup plan. So then the other one, the third one, is just doing the opposite. It relates cosecant and cotangent. So I'm going to divide everything by sine squared theta. And sine squared over sine squared is 1. Cosine squared over sine squared is cotangent. And 1 over sine squared is cosecant squared. So it's tangent squared plus 1 is secant squared. It's cotangent squared plus 1 is cosecant squared. Really, I just need to prioritize memorizing them, and I won't have to go through this every time. It's kind of like memorizing the unit circle versus not memorizing the unit circle. All right, with those in mind, and we won't need them for all of these, but it's good to have them refreshed. Let's go ahead and verify the identity. And again, we're going to follow very strict rules. We're going to go one step at a time, and we're going to just manipulate the left side. In fact, just think of it as not even an equation. Think of it as here's what we're starting with, and our target is to make it into secant theta. In other words, there is no equal sign. There's no equation. There's just the left side and trying to make it equal the target. Okay? So this one's very simple. Cosecant is 1 over sine of theta. And again, when in doubt, when you're not sure what to do, the number one thing is just turn everything into sine and cosine and see what happens. Tangent is sine of theta over cosine of theta. And obviously my sines cancel. And so I get 1 over cosine of theta equals. Try to keep your equals lined up. And then 1 over cosine of theta, of course, is secant of theta. And that was my target. So my identity has been proven. Little box says I'm done. All right. Part B, we've got some options. We could go the similar route and turn things into sine and cosine and see what happens. And that'll work out if we don't make any mistakes. But I think a more direct route to the answer would be simply to show that, hey, these are just conjugates of each other. And when I multiply conjugates together, I get the difference of two squares. So in other words, I'm going to FOIL these out, but I know the middle term is going to cancel out. So I'm not going to show it. Like if you show it, that's fine. But the short version is when there's math to be done, often that's the best first step. So when I multiply these together, I simply get cosecant squared theta. Middle stuff all cancels. And then the last would be getting negative cotangent squared theta. And I want to show that this equals 1. So I'm going to come and I'm going to do a substitution. And so we just reviewed that I have, looks like rule number 3. Cosecant squared is the same as 1 plus cotangent squared. So I am just going to do a substitution, and I'm going to turn cosecant squared into what it says it is. So then I'm just going to make this say 1 plus cotangent squared theta. I still have on minus cotangent squared theta. Still trying to show it equals 1. You can write the 1 or just leave it off. And of course, cotangent squared minus cotangent squared cancels out, and I'm left with 1 equals 1. All right, so on this question, if this was us 3 months into this, we've been doing it every day, we're all experts, I wouldn't feel the need to give any pointers on how I went from step 1 to step 2. But since this is brand new, and maybe I didn't have these notes at the top of the page, this would be a perfect example where off to the side, we probably just want to give a hint to whoever reads our problem that, hey, don't forget that cosecant squared theta is equal to 1 plus cotangent squared theta. And that's should be enough hint for you're like, oh, how did I get from step 1 to 2? Oh, I see. I used that trig identity. Okay, so that's the purpose of that. All right, let's look at a third one. And honestly, I did this one in class for one of the classes, and I made a bad decision that got me the answer, but it took, I don't know, 8-10 steps longer than necessary. So there are lots of journeys to getting the answer here. I like to think of these as puzzles, and your goal is to solve the puzzle in as few steps as possible. Not just solve the puzzle, but how can you do it the most efficient? So I'm looking at this problem, and I see that I've got a numerator with 2 terms divided by a denominator. So I can divide each of the terms on top by the denominator. So in other words, I get the tangent of theta over the tangent of theta plus the cotangent of theta over the tangent of theta. Now, there's lots of things I could do here. I could add these together, but that would just undo what I just did. Right? That would just put them back together. Obviously, tangent over tangent is 1. And then on any given day, I might approach this differently. Like I might turn everything over here like into cosine over sine and sine over cosine and have fraction over fraction and simplify. And honestly, that'll work just fine. But one thing I noticed today is I could turn cotangent into 1 over tangent, and then I could just keep everything in the tangent world. Or I could turn tangent into 1 over cotangent. Now, one of those choices is going to lead to almost like 2 steps in being done, and one is going to lead to about 10 steps. And what I'm noticing is my target. My target is cosecant squared. And I'm going to go back up to the top and review what we said. Cosecant squared is pretty much related to cotangent squared. So if I can turn the left side into some version of 1 plus cotangent squared, then I'm done. So the mistake I made the first time is I said, hey, let's turn this in. I'm going to erase this. Let's turn this into 1 over tangent divided by tangent. And that's fine. But then that gives me 1 over tangent squared. Wouldn't it be better if I did it the other way? Since we already know cotangent squared is related to cosecant squared. So instead of that, let's leave cotangent as cotangent. And let's turn tangent into 1 over cotangent. When I divide and fractions are involved, I know it means I need to multiply by the reciprocal instead. So that means I'm just going to multiply by cosine of theta over 1. And of course, that gives me 1 plus cosine squared theta. And I know that 1 plus cosine squared theta is the identity we just reviewed. It's simply cosecant squared theta, which is what I was trying to show it equals in the first place. And so we are done. Put a box. I always had to fight the urge to finish a problem. I always want to put a box around this, but that's not the answer, right? That's just the final step. The answer is everything we did to get there. So I try to avoid putting a box around just that final step. All right, so the more of these you do, the more they'll be comfortable, and maybe you'll come to appreciate them. Or maybe that's asking too much. All right, warm-up number 2. Simply want you to evaluate these 4 trig functions. Unit circle memorization, you got the answer before you even write the question. Don't have that memorized, you should have the answer about 10 seconds later. So sine of pi over 6, when in doubt, sketch a picture. Pi over 6 is a little bitty 30-degree angle here, and I know that that's going to be half and root 3 over 2. And so the sine is the y value, the sine is simply 1/2. On a unit circle, we don't have to do opposite over hypotenuse because our hypotenuse is defaulted to 1. But don't lose sight of the fact that it has to be a unit circle to do that. All right, so then 7 pi over 6, I'll go across here. That, of course, is the same exact angle, but now we're sitting over here in quadrant number 3. So we have the same y value of 1/2, but now it's negative 1/2. And 5 pi over 6 is the exact same triangle again, so we're going to have the same answer. This time, though, we're looking at a little triangle that gets drawn over in quadrant 2. And so now we know the y value is positive 1/2. And finally, 11 pi over 6 we know is over here. And so we're looking at negative 1/2. All right. Hopefully that's all good and fine. All right. So the reason I really want to do this warm-up question is because it leads to the formal discussion of what a reference angle is, because we just used a reference angle. So here we go. Let theta be an acute angle in standard position. Sorry. I don't know why you put the word acute in there. I saw it from below. Let theta be an angle in standard position. Its reference angle, theta prime, is the acute angle formed by the terminal side of theta and the horizontal axis. Okay, so let's say we have some angle whose terminal side ends over here in quadrant 2. So they're saying this is theta. And then theta prime, or the reference angle, is the angle that is right here. It's the acute angle formed from the terminal side and the nearest horizontal axis, right? So we're talking about this angle right here. So there's theta prime. And the reason that that's important is because, again, what we talked about just in the last problem, if we look at this right triangle formed over here in this quadrant with theta prime, that's how we're going to answer all the questions about the sine, cosine, tangent of theta, because they have the same xy coordinate right there, right? So if we are in quadrant 3, right, so theta opens all the way up to here. Then the acute angle formed with the horizontal axis would be this angle right here. So this little bit right here would be theta prime. And this original angle, theta, is here. But if I'm going to answer sine of theta, what I really need to do is analyze this little triangle created with theta prime, which is what we've been doing the whole time. And if my angle opens all the way into quadrant number 4, so here's theta, then we are talking about the reference angle being theta prime, this big right there. And that's, again, relevant because we can make a right triangle and answer all our trig functions. Because you got to remember, trig functions only work with right triangles. So somewhere in your picture, you've got to make a right triangle. All right. We've been doing this the whole time. That's just the formal of what a reference angle is. All right. So let's take a look here. Example 1. Let negative 3, 4 be a point on the terminal side of theta. So let me draw an X and Y axis. When in doubt, draw a picture. -3, +4, we're going to say is over here someplace. And that's my terminal side is going through that point. So here's the angle theta that we're talking about. I want you to find the sine of theta. Now, we know we can make a right triangle, and graphing the point -3, 4 would be moving over -3 this way and going up 4. Now, what we need to do is know when to and when to let go of the unit circle. This is not a unit circle. The answer to this question is not 4, because we know categorically that is not a unit circle. The hypotenuse is not 1, right? Because the hypotenuse has to be the longest side. And if that's 1, then how is that 4 and -3? So we cannot shortcut it to just being the y value. It does not work. We have to go back to the original. What does it mean to do sine? It means opposite over hypotenuse. So what we need to do now is figure out the hypotenuse of C. My hope is that you just recognize, oh, this is a 3, 4, 5 right triangle, and we know that this is 5, and we save ourselves some time. But if you don't know it, the missing side is the hypotenuse. And some of you are making this mistake early, and we need to stop. The hypotenuse is always the C value. Whether you know it or you don't know it, it's the C value. It's the equal to part. So in this case, we would just have 4 squared plus 3 squared equals C squared, which is 25. And so whether you recognize it or not, we should be able to find that C is 5. So now we just use our triangle. The sine of theta is going to be 4/5. The cosine of theta, pay attention to positive and negative. The x value is negative, so this is -3/5. And the tangent of theta would simply be opposite over adjacent. So that would make it -4/3. And I didn't ask for the other 3, but flip these over to find the other 3, or go back to the source and do it, hypotenuse over and figure it out. All right, so really nothing new. Just really want you to get away from the unit circle when appropriate. All right, so here's the same basic question. So this time I want you to do all 5, or 6, excuse me. Given that secant theta is 5, okay, and that theta is in quadrant 4. Now, what do I mean by that? I mean it ends in quadrant 4. So I'm not going to draw a circle because that gives the impression it's a unit circle. So I'm just going to draw an axis system. And if secant of theta is 5, what does that mean? So secant of theta equals 5. That means, so I'm just going to, I guess, fake a triangle here. I'll just pretend like the scale will not work out. So we're going to say that this is the angle in question. And so let's go ahead and just make a fake little right triangle here. And let's focus on our theta prime. So if secant is 5, secant is hypotenuse over adjacent. All right, so this is hypotenuse over adjacent. And if the hypotenuse over adjacent is 5, then we could say the hypotenuse is 5 and the adjacent is 1. So this would be 5 and this would be 1. Now, is it possible that the hypotenuse could be 25 and the leg could be 5? Because 25 divided by 5 is 1? Yes, it could be. We're just going to use the smallest, most basic one we can find and not sweat it. Because all I want is the ratios anyway. It doesn't really matter. It'll all work out in the end. You're just making it harder on yourself if you pick other values that divide to be 5. Okay, so here's what I was talking about with the Pythagorean theorem. We need to do a squared plus b squared equals c squared, but I've got evidence that some of you are just not focusing or you don't understand that the hypotenuse is always the c. So I'm missing a leg, call it a, call it b, it doesn't matter, but I'm missing that value. So I know we need to find a squared plus 1 squared equals 5 squared. Or in other words, a squared equals 25 minus 1, or a squared equals 24. A equals the square root of 24, which is 4 times 6. So a equals 2 square root of 6. And if the a value is 2 root 6, notice the location. We're going to make that negative. Okay, now we just answer the question. What is the sine? The sine of theta is the opposite, negative 2 root 6 over 5. The cosine of theta is going to be 1/5. We knew that because flip over the secant. Tangent is going to be negative 2 root 6 over 1, or just negative 2 root 6. Cosecant is flipping over sine. Okay, or go back to the source and realize it's just the hypotenuse over the opposite. Either way, we're going to get negative 5 over 2 root 6. And I want you to get good at just doing that in your head, even going directly to the answer if possible, but certainly being able to see that this is going to be negative 5 root 6 over 12. Rationalize your denominators. Secant of theta is the reciprocal of cosine, so it's 5 over 1, or just 5, either by flipping or going to the source, 5 over 1. And then cotangent of theta is 1 over 2 root 6, and it's going to be negative, which is negative root 6 over 12. All right, hopefully that's all okay. Go back and watch it again if you need to see it again, or come get some help. Let's see what else we've got in store. All right, this time a small twist on the question, but very related. This time we've got the information that tangent of theta is undefined, and that theta in question is between pi and 2 pi. So that would be an angle in quadrants 3 or 4. Solve for theta. All right, so if tangent of theta is undefined, that means we're looking at a fraction with maybe a number on top and a 0 in the denominator. And that number, right, so tangent is, so the opposite side, over the adjacent side, or unit circle, because I think that'll help us. The unit circle, like we know we have to have tangent is sine over cosine, or y over x. So however you want to look at this, we got to figure out, when is x 0? Tangent is sine over cosine. When is cosine 0? Cosine is 0 when x is 0. Tangent is y over x. However you want to look at it. What doesn't really work is looking at it strictly as a right triangle, because technically this is not a right triangle because we cannot draw a reference angle. How do I know that? Because if tangent of theta is undefined, then we're looking at an x value being 0. So we're looking at like this point here on a unit circle of 0, 1, or we're looking at 0, -1, because tangent is y over x. So -1 over 0 is undefined. 1 over 0 is undefined. I think I've over-talked this one. We want the answer between 0 and or pi and 2 pi, so we're looking for an answer down here. So the answer is angle that opens to there, 3 pi over 2. Tangent of 3 pi over 2 will be undefined. So this is a good example of unit circle helps us sometimes. Looking at a right triangle helps us sometimes. Know this in lots of different ways. All right, I'm pretty sure probably some of you are going to be confused by that. Please seek me out if you need me to go over that more directly. All right, and then we have the same basic question with maybe one that's easier, hard to say. This time I'm looking for all theta such that, by the way, this is the phrase, this means such that, or that belongs to the element. Actually, I'm wrong. That is an element of, my mistake. Is an element of. In other words, all thetas between 0 and 2 pi. Okay, so let's look at what we have. Secant of theta equals 2 root 3 over 3. If I'm going to be able to answer this question without a calculator, it has to be one that I know. So it has to be like the previous one where it's at an axis of x and y, or it has to have a reference angle that's a 30, 60, or 45-degree angle. So I'm looking at this, and unit circle helps me a little, but I don't have my secants memorized. So what I'm going to do is I'm going to look at this and really think about what this is telling me. And I'm recognizing this is a rationalized answer. So I'm going to sort of unrationalize it or view what it said before it was rationalized. This is 2 over square root of 3. So what kind of an angle has a secant that's 2 over the square root of 3, or that has a cosine of root 3 over 2? And that should have the alarm bells going off. Alarm, this is our 30, 60, 90. Pi over 3, pi over 6. All right. So now I know what I'm dealing with. Let's now think about this maybe from a unit circle perspective. I'm looking at a cosine of root 3 over 2. So cosine is the x value. That's going to be, this is root 3 over 2. This is a half. This is simply pi over 6. Right? Pi over 6, half, root 3 over 2, and 1. So find all theta such that secant is 2 root 3 over 3. And so secant is 1 over cosine. So we have 1 over root 3 over 2. Just verifying it, which is 1 times 2 over root 3, which is 2 over root 3, which is 2 root 3 over 3. So the answer is pi over 6. But I want all values. So you might think about giving me this answer, but that answer is not correct because the x value would be negative, root 3 over 2. So that would not be positive, that would be negative. So where's the only other place that it's going to be positive? That's going to be right here. So the answer is going to be pi over 6 or 11 pi over 6. We could have said negative pi over 6, but notice again, we want an angle that's between 0 and 2 pi. So we want to talk about it the right way, and it wants the answer there. All right, I hope that makes sense. I'm not sure I did a great job for anybody struggling, but if you come talk to me, I can break it down slower and approach it a different way. So just because you don't understand the way I explained it here, it doesn't mean there's not 10 other ways of talking about it, and we can get you across the line. We just need to get you in for some help. All right, I hope this video helps you in some way. Let me know if I can be of further service.